Hello, everybody. My name is Nate, and this is going to be a continuation of the previous video, which was getting started with Prefect. We're going to be taking the code that we wrote last time and talking about sort of the next step in terms of like infrastructure and configuration, which is decoupling our code that we wrote from the infrastructure that's going to run on, so that those things can change independently. Because maybe different people focus on writing code than focus on configuring infrastructure. So let's talk about how to do that with workers and work pools today. Just using where we left off with our code. So where did we leave off? Let's pull that over here. Where we left off is that we had some normal Python code that we have a couple functions. We call our couple functions in this main, which we decorate with a flow decorator, and then we sort of encapsulate important pieces of work or checkpoints with this task decorator and say, hey, this thing is important to be able to retry independently. It's important that I know that this block of code finishes correctly, or if I know that it fails, what have you. So what we did is we served this flow so that it became a deployment, one that we can trigger from the UI. Anyone who happens to be in the UI can trigger that. But ultimately, the infrastructure that's running my code is just my computer, and if I close my computer, the process dies. So how do we get something that looks more like a production system, where maybe your company bought a VM and you want to spin up a systemd process on that VM or something like that? So let's talk about workers, how we run them, and how they are associated to deployments. We'll start with the process worker because that's pretty easy to use, and then we'll talk about some limitations of the process worker and why it might lead you to a different choice. So let's get into it. What do we need to do in order to turn this thing into a deployment that doesn't block forever when you run the Python file? All we need to do is change serve, or we need to change, sorry, we need to change serve to from source and deploy. And I'll show you what that looks like. So we say from source, and that's like, where does our code live? So you're telling Prefect the source of your code, like where it lives. And then we have .deploy, which is the instruction to literally create the deployment. So what do we need to put in here? Let's start with deploy. We need to say our work pool name, which is the name of sort of the infrastructure configuration for our flow. And what I mean by that is if I do prefect work pool ls, we'll see a couple different types of infrastructure that I have at my fingertips here. There's like prefect managed infrastructure, which is just a container in the cloud that you don't need to worry about, that will run on your behalf. You'll see that we have a Cloud Run work pool, so that's a Cloud Run container that's on GCP, that's in my project, my VPC. There's a Kubernetes work pool, which is it's actually our company's internal cluster. However, there's a K8s test one, which has information about my Docker desktop Kubernetes context. So like each one of these work pools just represents at a high level the infrastructure that code may run on. And each one of these things is tweakable so that you can have different environment variables, you can have different memory requests if it's relevant. All work pools are just a way to configure a specific infrastructure for code to run on. So with that in mind, let's start with the, what do we have here? Local. We have a local process work pool. So let's choose that one because that one's easy to start with. I think we'll also need a name, so let's choose that. And now we need to fill in this from source business. And so what we'll do here to start is we'll just say that our code is stored in the file that it's currently in. Like, it doesn't need to be more complicated than that, right? And for now, no, it doesn't. So let's just say source, and that's going to be a string, and we'll just say that the current file, courtesy of dunder file, which is just a Python magic variable, we'll just get the current file's parent directory, and that's like the source. That directory is the source of our code, and then the actual entry point is the file that we currently live in. So let's do a little fancy Python business and say that this is, we'll use a walrus to say that this path itself is p, and that means that we can do a nice little f string. I think we want name because that includes the suffix. So name and then main to say that that's the decorated function that is truly the entry point of our business logic that we have written in this flow. So now we have a description of where the source code lives. It's in this file, and it's this function is the entry point, and we're going to deploy that. Send the Prefect server, in this case Prefect Cloud, a description of where our code lives and how it should be run, courtesy of our work pool. So let's go ahead and try this, and let's see if we failed in some specific way. So we could say Python main.py. Looks like you're deploying to a process work pool. If you're creating for local development, using serve is a great option. We touched on that before. It's not wrong. Serve is a great option, but we're building our way towards a more complex infrastructure situation here. So let's just go ahead, take the suggestions of the friendly CLI help here. It will basically create a flow run of our new deployment, let it bounce around in the Prefect world for a little bit, and then we'll start a worker, which is specifically listening for runs from deployments that are assigned to this work pool. And in our case, we just assigned this deployment to this work pool, so this worker is going to listen to runs sent to that work pool. It's kind of like a pub sub topic. Like the work pool is sort of like a topic, and then deployments are sort of assigned a topic, or send their runs to a topic. Anyways, we have successfully run our code on this process worker. Let's verify that life is making sense by going into the UI real quick. We'll pop it over here, and we should see that if we go into runs, the most recent one, Jovial Chamois, maybe, it just looks the same as last time. Our code just ran, except that this time we see that there's a work pool associated with our run, where we can go check out other things that have run in this work pool. So all that's great. So now let's do a Docker. Let's Dockerize our deployment. And why would we do this? Thinking back to a hypothetical I mentioned in the last video, which is like, what if we have 20 people who are all writing code, creating deployments like this, and they want to deploy to the same VM that our company purchased, where everything's going to run. And so if we just have one worker in that place, the issue is that this environment where Python, this virtual environment right here, is responsible for having all the Python dependencies that any flow that would run in this, like as a subprocess of this worker, like it would need all those dependencies, which means that if I have a flow that's, using NumPy 2 point whatever, and then someone else is using completely different Python dependencies, you would need to like rapidly install and uninstall, or use like some temporary directory to isolate each flow run's environment within the process. It's just like, this is why Docker exists, right? Like Docker is a super easy way to just spin up a totally isolated, fresh environment. Like do whatever you want to it, get it like exactly what you need and nothing more, and then as soon as it's done, you just tear it down, act like it never existed. And this is like a perfect situation where Docker is nice. So let's see what we have for ourselves. Docker work pool ls. We should already have a Docker work pool. And so we can go in the UI if we want to and see what this looks like. If I can remember where the UI is. Yeah, here we go. Work pools. Let's see, Docker work. We have some stuff, but the interesting stuff is in here where we can edit it. We can set volumes, which I'm not going to do right now. We can set memory limits, networks, whether or not to remove it, all this stuff. Registry credentials. We're not going to do much of that. We're just going to save what we have here, which is pretty bare bones work pool. And then we're going to do one other thing, which is, unless we mounted our container, which we can do with the volume section on our work pool, unless we mounted our container to our local file system, the container can't just like pull files from the host file system. So what is often done is like you take a third-party remote file system where you push your code like GitHub, and then you give the container the ability to pull down your code. And if it's a public repo, it's just a simple call. It's like a free API call. So I think let's do that. Let's just use GitHub because it's the simplest thing. That's where my code's going to go anyways. And I don't need to worry about giving the runtime container access in some way to my local file system, which you can do, by the way. So let's say instead of this file where my source code lives, we're going to say that this is literally just HTTPS, exactly like this. Except we're just going to do the repo.git. And then the entry point is going to be main, or I think we did new prefect project. Yeah, there we go. And that is a full description of where my code lives. It's in this repo right here. And with respect to that repo, it's in new prefect project and then main.py. Oh, we missed a little something. We need to say that this is the main function within main.py. So let's go ahead and recreate our deployment. We can say prefect or python main.py. That'll go ahead, should create the deployment. Nice. It looks like you're deploying to a process work pool. Ooh, good reminder. Thank you for the reminder. We want to use a Docker work, which is the name of my Docker work pool. Oops. So let's go into here. Let's try that again. We should not get that warning this time. Creating updating deployments. Great, no warning. Our thing is created. So let's go ahead and create the run just like we did before. And note that I do have Docker desktop on my computer, which means that I can just happily run this command, and it's going to use my Docker engine that I have set up. And sure enough, what do we have? We have the run that gets picked up. It is pulling the image that I must already have associated with this somehow. Let's figure out how exactly that happened. But we see first that our code ran as expected in a container. And what we should see, if we're quick enough, Docker PS. Oh, it already died. What about Docker PSA? Seconds. Let's grep for seconds. 18 seconds ago. Yeah, there we go. So we can see that we have a container that just exited, which was our flow run that ran successfully on Docker on my machine. Okay, so now if you imagine that you have that VM that we were talking about, you can just run a Docker worker on that VM, and people can create deployments, which are totally self-contained, and send them to that VM, and it can just happily run without caring about the specific dependencies of each deployment, which is pretty nice. It is usually a pretty necessary step that people have to take as they're going from maybe less sophisticated on-prem infrastructure on their way to cloud infrastructure. So let's quickly solve that puzzle of how it knew what image to use. So let's say prefect deployment. I want to inspect this deployment, and I want to see how it knew which thing to use. So we have no job variables, which is surprising. I guess it's not that surprising. But one thing you'll notice is that we have this pull step, which is, in terms of the API, it's what you get when you say from source some other place. We translate that from source call into a pull step, which is us telling the API, how do you get the code at runtime? And in this case, we get clone it from the place that you told us. So you could replace it with S3, GCS, or Bitbucket, or whatever you have. So let's. How did it know to use health check? That's the question of the hour here. Let's see if we can figure it out before it becomes tedious. Let's go into. I have a suspicion now. That it has to do with the work pool somehow, that I've maybe hard-coded an image into the work pool. Let's see. How do we do this? Image. And sure enough, okay, so we've hard-coded an image, which apparently has the dependencies I need to run this code. But let's go ahead and get rid of this because I don't want any weird things going on. I just want to use the Prefect base image, the normal image that would come stock if I didn't do anything in terms of configuration. So let's do Prefect deployment run again, and then we can say Prefect worker start, and that should pretty quickly spin up our run. So yeah, okay, here we go. Now we're pulling this image, which is the latest RC version that has Python 3.12, which is nice. And that took a little longer, probably because I haven't pulled that image before, but everything else seems to be going splendidly, swimmingly. Our code runs, and just as a check, I wasn't thumbs up, but yeah, our code did pass, so sure, thumbs up. If we go into runs, we should see that as per usual, our code happened, and we have this work pool associated where we could go in and look at other runs associated with this work pool. Okay, so now the world is your oyster. You can spin up a Prefect Docker worker in any old place that you have Docker installed, and it can just run containerized flows that, and the worker doesn't have to care about the dependencies, which is pretty nice. So now we've successfully decoupled the code that we write and the dependencies that it requires from the infrastructure that is needed to run that code, and that's almost true. And the astute among you might point out that, hey, like, what if my code is incredibly CPU bound and I just need a lot of memory and CPU requests? And then, of course, then you have some sort of dependency between the code that you're running and the infrastructure that it requires. But that's more on, it's more deeper into the infrastructure configuration weeds than I'm going to go today. However, I will say that we have both, like for Cloud Run work pool and Kubernetes work pool, you can just set memory requests or CPU requests on a flow run or deployment basis. So that's like totally covered. But I'll stop there for now. Hope that was helpful. See you in the next one.